All right, let's jump right into it. Welcome to This Explainer. Today, we're tackling something that really separates the seasoned engineering veterans from the rookies, and that is outdoor cable trays selection. Listen, if you're approaching a new project and your absolute first instinct is to crack open a manufacturer's catalog and just start picking out parts, well, stop right there. You're already heading down a path that almost always leads to field failures. Today, we're looking at a true veteran's blueprint. We're pulling directly from rigorous engineering frameworks to understand what actually makes an outdoor system survive. We're going to put on our senior electrical engineer hats today, and we are focusing heavily on the strict anti-corrosion and thermal verification standards that you absolutely must master.
So let me ask you a fundamental question. What actually governs the route of your cable tray once it's in service? Now, I know a lot of us instantly think about the cables, we think about the voltage, the capacity, the bending radius, the whole shebang. And hey, while all of that is obviously important, when you step outside, the cables are no longer the boss. The environment is the boss. If you want a system that lasts, you have to fundamentally shift your mindset. You aren't just designing a path for wires anymore, you are engineering a structural survival system against the elements.
So here is the veteran's blueprint we'll be covering today. First, site conditions and core drivers. Second, matching tray to outdoor reality. Third, the corrosion material matrix. Fourth, thermal and structural checks. And finally, anchoring and standards.
All right, kicking things off with Section 1, Site Conditions and Core Drivers. Let's look at the core variables. You know, the sheer infinite chaos of the outdoors can actually be distilled into 4 manageable mathematical variables. We're talking about corrosion, heat, wind, and contamination. Speaking strictly from a senior engineer's perspective, I cannot stress this enough. These 4 variables are the true dictators of your design. The precise answers you get when you measure these 4 conditions at your specific site, that is what dictates your material choice, your tray type, your support spacing, and whether or not you're going to use covers. If you skip this site condition checklist, you are essentially flying blind.
Moving right along to Section 2, matching tray to outdoor reality, choosing the right form. Okay, so we basically have 3 primary physical forms to work with in our toolkit: ladder, perforated, and solid bottom trays. And this perfectly illustrates that strict if this, then that logic of outdoor engineering. Which form fits which outdoor condition, and why? Well, a ladder tray offers maximum ventilation, right? Making it totally ideal if your primary driver is heat. But what if your core driver is heavy contamination, or maybe falling debris? Suddenly, those open rungs of a ladder are a massive liability, and a solid bottom tray becomes absolutely mandatory to shield those cables. A perforated tray kind of sits somewhere in the middle. The big takeaway here is that the physical form must follow the environmental function. That brings us to Section 3, the corrosion material matrix. Let's dig into those anti-corrosion standards. So here's the absolute most crucial point. Corrosion is literally the silent killer of outdoor infrastructure. Period. Our source framework maps out 5 distinct exposure conditions, ranging from relatively mild dry inland environments all the way up to severe coastal areas and industrial zones that require intense chemical washdowns. You have to select your material based precisely on where your site falls on this matrix. If you specify a standard indoor rated material for a chemical washdown zone, or say a light galvanization instead of 316L stainless steel or fiberglass for a really salty coastal environment, you are practically guaranteeing a catastrophic failure in the field. The environment will literally eat the tray alive. You have got to match the metallurgical defense to the specific environmental attack.
Next up is Section 4, crucial thermal and structural checks. These are your make or break design checks. Now, this right here is probably the single most frequently skipped thermal check in the entire industry: solar gain. When amateurs calculate the thermal load of a tray, they usually just look at the heat generated by the cables themselves. But veteran engineers know you have to account for that giant ball of fire in the sky. Solar gain is the added heat from direct sun exposure, and let me tell you, it fundamentally changes your thermal calculations. If your route is just baking in the afternoon sun, the ambient temperature inside that tray spikes dramatically. If you don't run the thermal verification for solar gain, you're going to miss the necessary ampacity derating factors, causing your cables to completely overheat and potentially fail. And right alongside those thermal checks, we have the structural checks, specifically cover dead load. Remember earlier when we talked about adding solid covers to protect against contamination? Well, those covers are heavy. Cover dead load is the actual physical weight of those tray covers.
If you specify covers, but you somehow forget to add their weight to your structural calculations, your support spacing is going to be way too wide. The result, you're looking at sagging trays, highly stressed joints, or just a complete physical collapse out in the field.
Honestly, it all comes down to this really stark comparison. Amateurs treat cable trays like a grocery list. They just order from a catalog based on dimensions alone. Pros run the math. They vigorously verify those solar gain thermal limits, and they calculate the dead load structural spacing. Doing these checks isn't just about being thorough, guys. It is the very definition of professional engineering.
Finally, we reach Section 5, Anchoring in International Standards. Let's talk global compliance. Because proper engineering doesn't just rely on gut intuition, right? It has to be firmly anchored in rigorous global compliance standards. Our source material highlights manufacturers like Xinma, who produce systems that strictly comply with heavy-hitting global standards like IEC 61537, NEMA VE1, BSEN 5085, and GB 31251. These standards are your ultimate safety net. They give you the verified, tested data you actually need to validate your route against all those corrosion, thermal, and structural checks we just went over.
And look, we know for a fact that this rigorous framework works because it's actively deployed in some of the absolute most unforgiving environments on Earth. Using these exact strict anti-corrosion and thermal guidelines, Xinma's cable trays, busways, and seismic racing are successfully utilized in massive data centers, incredibly complex rail transit systems, harsh industrial plants, and massive commercial buildings. These are zero-failure environments, and they demand the exact veteran blueprint that we've just walked through today. So as we wrap up this explainer, I really want to leave you with one final, kind of provocative question to chew on before you start your very next project. Are you just ordering parts, or are you actually engineering the route? Because when you respect the environment, calculate for that solar gain, and verify everything against global standards, you're not just buying metal, you are building resilience. Thanks so much for joining me on this deep dive. Take this veteran's blueprint, apply it rigorously, and start engineering with absolute confidence.